Okay, everybody, I am Mr. Auerbach. I will be teaching you the stoichiometry today. And stoichiometry, worst word in chemistry, and your last uphill climb for the semester. And it's actually, the concept is simple, but like everything else in our chemistry adventure, figuring out what you're supposed to do is kind of the challenge, right? And the how to do it happens later. But I'm here to tell you that it's really one small task sandwiched in between some other skills you know how to do. What do I mean by that? Well, let's look at the definition. Use a balanced chemical equation or reaction. Let's come up with one of those first. How about let's just do the one we started talking about yesterday. Let's see, 3H2 plus N2 yields 2NH3. Yeah, there's a balanced chemical equation for you. It's simple. And the kind of problems that you would get in stoichiometry asked you to go from one amount to another. So if I say, given 127 liters of hydrogen gas, how many grams of ammonia, NH3, will be produced? Yeah, so using a balanced chemical equation to find amounts of one reactant or product given an amount of another product or reactant. So in other words, you're always given one thing in an equation and asked to find another. And it can be on either side. This one asks if I have 127 liters of hydrogen gas, how many grams of ammonia? But I could just as easily ask how many molecules of nitrogen gas, or how many grams, or how many liters will be required to react all of this, or something. So it's a powerful tool, but it's also a confusing tool until you figure out what exactly you're driving when you do it. So let's work this out. And now I want to go over here to the other board because I have a scheme, a model for you to use. So let me walk this over here. Don't worry, you are perfectly safe. Everything is okay. Maybe. Okay, maybe this. Not bad. Except for the chords. Sorry about the chords. That's better. Okay. All right. So we're over here to solve this problem now. Let me get my marker. So it always works like this. There's always 3 steps to stoichiometry. First step is a conversion. You know how to do this. Always the first step is a conversion because I gave you, 127 liters of hydrogen gas. Yep. Yeah, so that's your given, right? So you want to find the moles of given. That's the first step. Always just going from whether I give you liters, particles, or mass, you're going to figure out how many moles that is. Right? And once I know the moles of my given, then I will convert. There's the last problem. The actual stoichiometry is using the mole ratio from the chemical equation to figure out how many moles of my wanted that is. But first step is something we know how to do, right? Converting from liters to moles. I'm just going to do this very simply and do 127 liters H2 divided by 20 22.4 liters. And that's going to give me my number of moles, right? I have a calculator right here. 127 divided by 22.4. That's going to give me five. I'm going to say 5.7 moles. I don't know if we can see that. All right, here equals 5.7 moles of H2. So that's what goes up here, 5.7 moles H2. And so the thing of stoichiometry is that if I know how many moles of anything I have, I can convert it to moles of anything else in that chemical equation using the ratio. And in this case, the ratio, I'll rewrite our equation right here, 3H2 plus N2 yields 2NH3. And so the ratio I'm talking about when I want to solve this is the ratio of moles of hydrogen to moles of ammonia. And that's it. That's all I have to do. And this is where what you're about to see comes from. And so now in this section, this is the stoichiometry. I will put my, 5.7 moles of H2, and then I'm just going to multiply it times the conversion factor that's there to make moles of H2 go away. So I put H2 on the bottom of the conversion factor because that'll put these over each other and they'll cancel out. And I want moles of ammonia, moles of NH3, up here because that's what I'm going for, right? I want moles of NH3 in this case to be my wanted, given and wanted. And so now I just go to my chemical equation and I put the things in there that belong. So I have moles of NH3 on top. Well, in the chemical equation there are 2 moles of NH3. And moles of H2 on the bottom. In the chemical equation there are 3 moles of hydrogen. So it's multiplying times a ratio that converts from moles of hydrogen, which cancels out, leaves you with moles of ammonia. And so now it's just, well, it's multi-step, right? Let's combine the fraction. We have 5.7 times 2 moles NH3 over 3, right? That's the only thing left. All the labels are gone. And so we can string this out a little bit, I guess, and let me get my calculator here. Here it is. So the way I would do this, I'll just do 5.7 times 2. And I'll divide that number by 3. It gives me 3.8 moles of NH3. 3.8 moles NH3. Now let's stop and ask ourselves if that answer makes sense. It pretty much makes sense to me. It's about 2/3 of the amount, right? 2/3 of the amount, and that sort of makes sense. I see a hand.
Yeah. So what was the second and third steps called, just so I can write them down?
This is the stoichiometry step.
Okay.
Right, well this is only one step. So the second of 3 steps really is the stoichiometry. Right, so this is, when we say you're doing stoichiometry, it's this part right here, which is just using the ratios in the chemical equation to go from moles of your given to moles of your wanted. And then after that, it's just another conversion. So we have 3.8 moles of NH3. Right? And so now it's just another conversion, and that's sort of the point I'm trying to make to y'all, is that the stoic step is the ratio. That's the only new thing. Converting from liters to moles, we've been doing for a week now, and converting from moles to mass, particles, or volume, we've been doing that also for a while now. So this is the only sort of alien step, and now I just have to go from my 3.8 moles of NH3 to, what unit do I ask for? How many grams of NH3 will be produced? So now it's just a matter of 3.8 moles times NH3, 14, 15, 16, 17, I'm going to say 17 grams per mole. So then 64.6 grams of NH3 will be produced. So that's 64.6. I don't know if that made it on the camera. Let me just see if that's actually on there. Oopsie. There we go. Okay. Anyway, that is how you do these problems. And thank you very much. I'm going to turn this off now.